Hello everyone, Cody here. We're going to be covering pooling layers in convolutional neural nets today. So CNNs have three major layers when it comes to building them. The first one is a convolutional layer. Second one is a pooling layer. The last one's a fully connected layer. Now the pooling layer is basically a way to kind of consolidate the features of any specific feature mapping that happened during a convolutional layer and try to not, make overfitting happen. So, quick review: CNN, the convolutional neural net, uses a specific filter, like this right here, which is a slight curve. It compiles it into a mathematical vector like this, and then it multiplies the vector of a sample of the image. So this yellow box is this visually to us, and this is the vector representation for the machine, and then this is the filter right here. So it takes this box, it does a vector multiplication and summing of the inputs here, and puts output into a single number, and it does that across the entire image until it has one little much smaller vector, because as it scans across, it's throwing all these together. So this right here is what we're going to be talking about, is types of pooling. And for example, one way to do it is called max pooling. So max pooling takes these, let me scroll, this series of vectors right here that had already been pushed out by feature detection and spits it into another smaller little filter. So it takes this little sampling and then it moves over. And right now, this one's an example is a stride of 2. So it takes these 4 boxes, 2 pixels wide by 2 pixels down, which is what they mean by a 2 times 2 filter and a 2 stride. And then it moves over 2. So 1, 2, and then it takes the max number out of these. Now, there's a bunch of different ways to do this. There's a lot of reading that you can do all around this topic. Whether you average them together and divide by the number, or you pull the highest ranks one, or you remove the top and the lowest and add the 2 together and divide them and all. I mean, there's so many different ways to do this. But for this demonstration, this is exactly what's happening. So then that little vector gets kind of pushed into this other smaller series of data. So like here's an example of where this is using ReLU. So what's happening is this is the input. So the black is a negative number, usually like a below 0. And then the white is a positive value. And the brighter the whiteness, the more likely, or not the more likely, but the higher the number is. So what happens, one methodology to do this for CNNs is to like wipe away all the negative numbers. So then all you see is kind of like this just a little bit of an outline of whatever the ridges are, which is what you kind of see similarly when it's doing edge detection here. So if we were to take kind of this rectified image that was above here, and we did max pooling, this is kind of like this weird giant chunk of like reducing the overfitting, because right here there's a lot of granular details, where right here, if you were just to take the max number out of those samples and then box them together, you get a chunkier, much more abstract view of the data itself. And because of that, this is kind of like the go-to that I've seen a lot of people use, is max pooling. Where if you use the sum, you can see that it's a completely different output, visually at least. And there's different reasons for and why, and we won't get into it. The whole point of this is just to kind of demonstrate, the idea of once you've done a convolutional neural net, or once you've done the convolutional layer, you've done some feature mapping, it gets itself to another vector. This vector then goes off and becomes its own little vector, and in some libraries it would be considered like a tensor because of the output based off of the pooling techniques as well as like the API. And then from there it just kind of keeps going on and on and on until you get more sophisticated feature detection. It could be eyes, it could be ears, it could be anything, and then the pooling keeps going. The pooling happens, almost always after a convolutional layer. So the only layer that's left is the fully connected layer, and that's the only layer that you only do once. And that layer is designed to be the end state of that. And in our next video, why don't we go in and just talk high level on why, that happens to be the case.